solve quadratic equation and transform quadratic expression and understand the properties of parabolas. Completing the square allows us to rewrite a quadratic expression in a form that makes it easier to solve and analyze. After topic objective, by the end of the lesson, the learner should be able to convert a quadratic equation into a perfect square form, solve quadratic equation by completing the square, derive the quadratic formula using the method of completing the square, apply and completing the square to analyze the vertex for the quadratic function. We have the references, that is Kelby Mathematics and Discovery Mathematics Book 3. We have the discussion forum and the topic quiz at the end of the lesson. Let's start. In this section, this expression given here, the x squared plus 6x plus 9, that is equals to x plus 3 squared. These expressions are perfect squares, and we shall now see ways of making any quadratic expression a perfect square. And we say that any quadratic equation can be simplified and presented in the form of ax squared plus bx plus c, where a, b, and c are constant and a is not equal to 0. We shall first deal with the cases where a is equals to 1, as in Roman 1 and 3 above. We identify the similar expression which are perfect squares from the exercise. We have the example. What must be added to x squared plus 10x to make it a perfect square? And the solution, we let the number to be added to be a constant, then it will be x squared plus 10x plus c is a perfect square. Therefore, you divide by 2 to get, and we square to get c, that is 25. Alternatively, we let the number to be added be a constant c. Therefore, x squared plus 10x plus c is equals to x plus, that is a constant, k squared, where k is another constant. So x squared plus 10x plus c is equals to x squared plus 2kx plus k squared. We compare now the coefficients of x. We divide by 2, both sides we get k to be 5. After comparing the constant terms, that is c is equals to k squared, but k, we add k to be 5. Therefore, c will be equal to 5 squared, that is 25. We have example 2. What must be added to x squared plus dash plus 36 to make it a perfect squared? We let the term to be added be bx, where b is a constant. Then the equation will be x squared plus bx plus 36 is a perfect square now. Therefore, we say that b over 2 squared will give us the c, that is 36. Taking the square root of both sides, b over 2 square root of 36, b over 2 will be equal to plus or minus 6. And our p will be 12 or negative 12. Thus, the term to be added is 12x or negative 12x. Alternatively, we let the number to be added be bx, where b is a constant. Then x squared plus bx plus 36 is equals to x plus m squared. We introduce another constant, that is m. So x squared plus bx plus 36 is equals to x squared plus 2mx plus m squared. Now we compare the constant, we equate. So m squared is equals to 36. We square root 36, we get m is equals to plus or minus 6. We compare the coefficients of x, and b is equals to 2m. When m is equals to 6, b is equals to 12, and when m is equals to negative 6, b is equals to negative 12. The term to be added is therefore 12x and or negative 12x. We shall now consider situation where a is not equal to 1 and is not 0, as in 4x squared minus 12x plus 9 is equals to, when we factorize this, we get 2x minus 6 squared, and 9x squared plus 6x plus 1, we get 3x plus 1 squared. We identify the similar expression in exercise given earlier. We'll notice that in all cases, b over 2, we square it, we get AC. And we shall use this relation to make expression the perfect squares. We have the example here. What must be added to 25x squared plus dash plus 9 to make it a perfect square? In the solution, we let the term to be added to be bx, then 25x squared plus bx plus 9 is a perfect square. Therefore, b over 2, we square, we get 25, we multiply by 9, so b over 2 squared is equals to 225. To get b alone, we square root, we get plus or minus 50. So our b is equals to 30 or negative 30. The term to be added as is 30x or negative 30x. We have example 4. What must be added to dash 40x plus 25 to make it a perfect square? We let the missing term be ax squared, then ax squared minus 40x plus 25 is a perfect square. Therefore, negative 40 plus 2 we square is equals to 25a. So 400 is equals to 25a. To get a, we divide both sides by 25. A will be 16. And we have an exercise here. Add the missing terms of the following expression to make them perfect squares. We can try it out with the lesson. And then we have the solutions of quadratic equations now by completing the square. We consider the quadratic equation x squared plus 4x minus 12 is equal to 0. And adding 12 to both sides, we add 12 on this side and we add 12 on this side. We have x squared plus 4x is equals to 12. The expression on the left hand side can be made a perfect square by adding 4. We add 4 on the left hand side, we get x squared plus 4x plus 4 is equals to 16. Then now we factor the left hand side, we get x plus 2, x plus 2 squared is equals to 16. We take the square root, x plus 2 is equals to root 16. So x plus 2 will be equal to plus or minus 4. Our x now will be 2 or negative 6. Thus, we have solved the quadratic equation above by making use of an expression which is a perfect square. This method of solving a quadratic equation is known as the completing square method. We have another example, example 6 here. We solve the equation 2x squared plus 4x plus 1 is equals to 0 using the method of completing. Now, by subtracting 1 from both sides, we get 2x squared plus 4x is equals to negative 1. We make the coefficient of x squared 1 by dividing through by 2. X squared plus 2x is equals to negative half. Adding 1 to complete the square on the left hand side, we have it as x squared plus 2x plus 1 is equals to half. X plus 1 squared, we get it will be equal to a half. We square root the half, we get x is equals to negative 1 plus or minus the square root of 0.5. Our x will be equal to negative 1 plus or minus 0.7071. We can deal with another example here before we close the session. Solve x squared plus 5x plus 1 is equals to 0 using the completing square method. We subtract 1 from both sides and proceeded to complete the square on the left hand side. So x squared plus 5x is equals to negative 1. X squared plus 5x plus 5 over 2 squared is equals to 5 over 2 squared minus 1. So x squared plus 5x plus 25 over 4 is equals to 21 over 4. We factor out the left hand side, we get x into, we get x plus 5 over 2, the square, which is equals to 21 over 4. Now we take the square root on the both sides. So x plus 5 over 2 is equals to the square root of 25 over 4. So our x will be equal to negative 5 over 2 plus or minus 4.583. When you do your working, you divide by 2, you will get 0.417 you divide by 2 or 9.583 divided by 2. Therefore, our x will be equal to 0.2085 or negative 4.792. We have a note there. The method of completing the square enables us to solve quadratic equations which cannot be solved by factorization. Thank you.